All right, I'm going to do some more examples on factoring by grouping. So the next one in your notes is x to the third plus x squared plus x plus 1. Once again, the first thing you want to do is find out, is there a greatest common factor that I can take out of here? But the only thing they share is a 1, and it's useless to take out a 1. And this doesn't have an x, so I have no greatest common factor. The next thing I do is I just take a look at the first two numbers and I say, what can I take out of there? Well, the greatest common factor I can take out there is an x squared. If I take out an x squared, well, x to the third divided by x squared just leaves me x. This is a plus, so this will be a plus. X squared divided by x squared is a 1. If this is a plus, I'm going to put a plus here. There's nothing I can take out of here, but I have to have a number there because I have to have something that will go with this. So I have to take out at least a 1. So then I'll be left with x plus 1. Remember, these two parentheses have to be the same. So the two numbers I took out is my first factor. So x squared plus 1 is my first factor. And the stuff that's in parentheses, I only write once as my second factor. So x squared, x to the third plus x squared plus x plus 1 factors down to x squared plus 1, x plus 1. And you could multiply this back, FOIL it back out to make sure that you get back there. All right, let me do another example. All right, the next example they give you is 6x to the third minus 9x squared plus 4x minus 6. Again, I'm going to look to see if I can take out a greatest common factor. Well, I could take a 3 out of those, but I can't take a 3 there. And this guy doesn't have an x, so I can't take out an x. So if there's no greatest common factor, I'm going to start by taking a look at those two. What can I take out between a 6 and a 9? I can take out a 3. Between x to the third and x squared, I can take out an x squared. If I divide 6 by 3, I'm going to get a 2. And x to the third minus x squared is just x. If this is minus, this will be minus. 9 divided by 3 will give me 3. X squared divided by x squared is just 1. I'm going to bring down the plus sign. Between the 4 and the 6, I can take out a 2, and that'll leave me with a 2x minus 3. Again, these two parentheses are the same, so that works out well. The things I took out of the parentheses is my first factor. And the stuff in parentheses only written once is my second factor. So now I have factored out that polynomial. All right, let me do the next example. The next one is 7x to the third minus 4x squared minus 7x plus 4. Again, I don't see any greatest common factor that I can take out. I'm going to start by taking a look at just those two. Well, there's no greatest common factor for the numbers, but there is for the variables. So I can take out an x squared. If I do that, I'm left with 7x minus 4. I'm going to look at these two. Again, if this is negative, that has to be negative. Again, there's no numbers I can take out. There's no variables I can take out, but I have to take out at least a 1. And then I'm left with 7x. Again, remember, this now has to be minus 4 because a minus times a minus will give me that positive there. So you always got to check. If you put a minus sign here, make sure you check that second sign there. So the stuff I took out is the same, so that means that it works. So x squared minus 1 is my first factor, and 7x minus 4 is my second factor. But you have to remember, this is one of our special patterns that you had learned earlier. If you remember, when you have a squared minus b squared, that's going to factor to a plus b and a minus b. So you always have to look to see, can I factor this any further, especially if there's a squared there. So this is actually going to factor into x minus 1 x plus 1, and then you're going to bring this one back down, 7x minus 4. So now this is fully factored. And the last example that they gave you is 12x to the 5th plus 4x to the 4th plus 42x to the 3rd plus 14x squared. So once again, don't forget to look to see if there's a common factor. Well, it looks like they're all divisible by 2, and I have an x squared, so it looks like they're all divisible by 2x squared. So 12 divided by 2 will give me a 6. X to the 5th divided by x squared will give me an x to the 3rd. 4 divided by 2 will give me a 2. X to the 4th divided by x squared will give me an x squared. 42 divided by 2 will give me a 21. X to the 3rd divided by x squared will give me an x. 14 divided by 2 is a 7, and x squared divided by x squared is just 1. So now I have taken out the greatest common factor. I'm going to just leave him alone for a minute. We'll put him on at the very end, but let's just focus our attention now to this one here. Now that it has 4 terms, I'm going to do our factor by grouping. I'm going to look at these two, and I'm going to say, is there a greatest common factor I can take out of those? Well, between 6 and 2, I can take out a 2, and between x to the 3rd and x squared, I can take out an x squared. 6 divided by 2 is 3, x to the 3rd divided by x squared is an x, and then 2x squared divided by 2x squared will be a 1. Then I'm going to take a look at the next two here, and it looks like I can take out a 7. So 21 divided by 7 will give me a 3, and there's no x, so 3x, and 7 divided by 7 is a 1. That's good because these two parentheses are exactly the same. So what that tells me is that this polynomial right here factors out into 2x squared plus 7, putting those two together, and 3x plus 1. But I can't forget that I took that 2x squared out initially, so I have to still put him back out front, and then this will be fully factored. This has an x squared in it, so I have to at least check to see if it is one of my special patterns, but it's not, so I'm done. Let me know if you have questions.